1 second. Okay. So I think I can do that. Oh, okay, there you go. Oh my god. All right. I'm not sure if this is working, but I will do my try. So welcome everyone to this talk about coding with purpose. I actually need it. Oh. Okay. Does it work? No. Okay. Well. The reason why I chose this is because usually we tend to do things without trying to give it a meaning what we do. So this talk tries to give you a really amazing way to think when you're actually doing stuff, in this case coding. So if we continue, well, for the ones who don't know me, I guess most of you, I'm Stanley Morales. I'm a software engineer at UV Data. This is my information for contact. But the second one, it's not exactly for coding. I just also do photography. So in case that you also want to see something that I do in photography, not very amazing, I would say, but I like it. So if you want to take a look, this is my username. And starting with this, I wonder if you have experienced this situation before. You need either to do something fast or you just try to take your time and then something correctly. But before continuing on this part, I would like to ask, who of you likes actually doing testing?
Writing tests or doing tests?
Like, if you like it.
Writing tests or doing tests?
Write the test. Okay, none of you. Okay, there is one. Oh, two. Okay, three. Okay, there are more. And how many of you do testing on their daily basics? Okay, so there are more people now. Well, actually, I would say the same. Well, my goal is that after today, if you don't actively do it, at least you will be interested. So let's continue with this, because something that usually happens when we are writing code, we say, okay, I'm just going to go to my computer, I'm going to write some code, and hopefully what I'll do will make sense, and then I will just pass it to review, and I hope everything is going to be fine. Let's see if there is a bug, I will just fix it later. But something that happens is that we need to consider some thoughts that we have about testing first. First, I don't know if you might be identified, but testing is time-consuming and boring. Could be. It can be time-consuming, but compared to what first? Like compared to being debugging all the time, every time you have a new bug and you say, okay, I don't know where this bug is coming from, so you just open the DevTools and you see maybe it's coming from here, so you make some calls to the APIs and see, oh, it might be coming from the outside world, so that might be the reason. But you spend the whole day and then you don't realize where is actually the problem. So if it's time-consuming, you might be also considering what you actually do, that you might be thinking, oh no, this is actually taking my time instead of doing the stuff correctly. Because if we don't fix a bug really early, with this graph, we can see just a bit in detail what happens, like the cost of fixing a bug in the stage that is happening. So obviously, in terms of the requirements, we don't actually have anything in our control. It's mostly for the stories and the people who are working on this part. But in our side, as developers, we know that we can fix that pretty early while we are developing. And then also while we do integration testing, but it's not as hard to do, especially if you go on the other stages and then the customer says, oh, we found a bug. Two things happen. First, you need to go back to your code, hoping that you remember what you did, and try to fix that, considering that it also has a cost inside and it has some consequences, because there are also, like, the customer is not happy anymore, then it will be complaining, then there are some delays, and then you get more stress, and you say, yeah, but testing is time consuming. You might be thinking twice now. There are some problems that happen when we are not testing, actually. So if you just mention some of them, like bugs in production are not really nice to work with, especially if you don't know that code, and especially, even more especially, it is legacy. The customer satisfaction can have even more problems than you might think, because if at the end there are no customers, you don't even have a job. So you can consider this part. and also some even bigger problems that comes with security vulnerabilities, and also the code might be working as you expect, but at the same time there might be some bugs that don't prevent the app to work from working, but there are still some inefficiency in terms of performance that you haven't seen, and maybe you don't care, but it's actually something that we consider. At the same time, fixing a bug can be really expensive in terms not just on money for the company, but also for you as a developer. If you are trying to fix something that, let's say in 2 months you go back to your code that you wrote, but you don't remember, this is even costly, and you have a deadline to follow, so there is even more pressure on you. And because of that, you have delayed releases. If it takes more time than you expected, then some regulatory compliances if you're following some standards and the company is being checked on it. The lack of documentation. For this part, I would say that the good documentation is not just the documentation by itself, but it's also part of the testing that you do, and at the same time, in the code, the way that you write code, like putting good variable names and some stuff that it's easier for other developers to communicate with through the code. And by combining all this, there is authenticity. You might be thinking, okay, I already fixed the issue, but you don't know if you already broke something, or if you actually fixed what you were pretending to fix. So coming back to this, some thoughts that we have about testing is that manual testing is not good as now, because we have some tools that we might be thinking. But automated testing, yeah, it's trendy, but at the same time, it doesn't replace the possibility to work for us as in unit testing, because mostly automated testing is focused on the high-level stuff and some details that don't cover in the low level. So usually the details and how the application is built. And as you might have been heard before, the evil is in the details. So unit testing will still be as important. Maybe it can be complemented. So testing goes after development? Not exactly. For this part, we kind of know that when you're testing something, you need to know what you're testing. And I will show this a little bit further. But for now, you have to know that testing has to be at least at the same time while developing, or even before. Then some other stuff is like testing eliminates all risk. Even if this talk is about testing and how good this could be for you, I have to admit that it's not 100% error-free. Once you are developing, we have to remember that we are humans and we still make mistakes. And the idea of doing testing is just reduces the amount of errors that you can create by developing. So it's kind of a way to avoid less mistakes. But it depends on how you do it. You can reduce a huge amount of mistakes in the future. And then the most common one, that testing stops me from being productive. Okay, so welcome for test-driven development, guys. In this definition, if I just want to show you pretty quickly, it's just an idea of working with tests where we actually work first on the test and then we work on the code. But as a philosophy for me, I would say that it's just go exactly at the same time. There are code that when we implement on test, and at the same time it can be actually used as the code. So writing tests in this time help us to write code in a way that helps us to have a guide, and at the same time it validates what we are doing as long as we are testing all the steps. So we are just writing enough code to actually make the test pass. I mean, nothing more, nothing else. So by following with this example, yeah, we have test-driven development, but I have to admit that there are some other options. I know that sometimes we have that mindset, like which one is better? What should I do if I have this other option? Oh, this company uses this methodology, so maybe we are outdated. No, actually there are, yeah, of course, there are some others like behavior-driven development or acceptance test-driven development. But the good thing is that they are not one against the other. They can even work together, and they focus on different aspects. So we can even make it work together in a very nice way. I wanted to reflect it here in this shape. I focus on test-driven development especially because we are the developers, and since we don't have much control of what is happening outside us, we might be thinking that we have to do our best to do everything as general as possible. If tomorrow the idea of the product was not what they intended to do, well, we are prepared to fix it and don't break our head to say, okay, I have another idea of how to do this from zero because what we did is not working anymore. So that's why test-driven development is mostly for us. Behavior-driven development is actually for the whole team. So it participates the product owner, some people, more people in the team. Since one focuses on the stories, us on the code, and we actually focus on the software maintainability, and that also is good for other developers to join, and they don't have a break in the head to say, oh, how does this work? How this is being structured? I don't know. This is a good way to solve it. And they also do it, but guided through the product maintainability. As well as we focus on the low-level stuff, and the rest of them, they focus on the high-level details. I wouldn't say that behavior-driven development is something that we might do it in our case for coding, but I think make it as general as possible and not putting everything around how the business logic is being managed. I guess it's better, in my opinion. But as long as we focus on building the thing right, we are good. As long as well, on the other side, they also work in building the right thing. By combining both, we can say that we are using acceptance test-driven development. So the idea for us as developers, as I mentioned, we are going to focus on this test-driven development. And I don't know if you have heard about this before, but this is my way to think about once we work on test-driven development. Because first, what it does for you is to think. You don't have to write code and think, maybe this is going to work. No, we have to think now and say, okay, what do I need? Where do I need to do it? Once you have this in mind, once you have a clear idea of what you have to do, well, then you go to your code, and then you say, okay, I will start making some modifications, or actually it's a new feature, so I will add some code. But after that, what is happening in this moment is that you're just writing your test, and this test just have to focus exactly on what you're doing. So you don't need to add so many dependencies. You don't have to create so many stuff that don't really make sense. Just exactly what you need to write the test, and it works successfully. But of course, since you are working first on the test, this also means that there are some classes that might be not defined, some methods that still don't exist. So that's why this is the red phase, and then you go to the other. So you are writing and refactoring code in order to continue testing and go back to your test and continue making the test until it passes. Once you know that it passes, well, you have enough code to make those tests pass, so you can even commit what you just did. And this works pretty well with CI/CD because at the end, you are never breaking anything, and everything you're providing is something new that the users can already basically test to work with. So once you finish that, I personally prefer to verify what I just did. Maybe I missed one more test, maybe something I needed to do. But after that, you might be thinking that, okay, it's time to go to the next one. And then you repeat the process. I hope it's clear. We might have some potential blockers, as I mentioned. One of those things is it really necessary what we are building? Because there are some tests about some methods, and I might be thinking, I was one of the ones who said, I don't even need testing. Sometimes there is just one method that says, I take one number, and there's another number. They just sum, or they divide, and that's all they do. It's nothing that complex. I don't even need to test it. But we don't even consider, like, are we sure that we are just working with numbers? What happens if the user can send a string, or even a code injection? Or what happens if they divide by 0? Are we handling those errors? So those are the questions that you might be asking yourself before thinking if you actually need a test for something. And if it's too difficult, I go outside the code for a moment, and you know that you're not working alone, so you can always ask. You can actually ask for the requirements to see, well, maybe I don't need to write tests about this, or maybe I don't even implement this solution. But depending on that, well, you might be trying to find one of those solutions to ask, to experiment. As developers, we can always do something like that, or do some research. The idea is always to learn. And testing shouldn't be that difficult. Actually, doing it in the right way should be really easy, and I will show you pretty quickly. But for now, this is the kind of process that you might be having in mind, where no matter what the situation that happens to you, you shouldn't be blocked. The nice thing about Flutter is that we have a huge community, as you can see right now, and we are everyone around us just to help us, and I think that's pretty nice, and that's why I want to do this presentation as well. Of course, talking about tests, that means that I can talk just about this without talking about architecture. Everything that we implement, all the features, all the implementation that is being created for our project has to be based on architecture that we choose. You can choose any of them as long as you take two things in mind: the separation of concerns and loose coupling. So maybe you have one class, and that class don't have any knowledge about what the other class is doing, but you know, as long as they are working with this class, you are just getting what you need, and that's only what you should be caring about this class. So some ideas like that, you might be using the onion architecture, or the event-driven architecture, the microservice architecture, or the most common one from Dr. Bob, the clean architecture. So this is something that we need to work very closely when we are working with tests, because that will make our life much easier when it comes to testing. If we do this, well, we have some really nice benefits that we can enjoy in life, and we can say, oh, I was born to be a developer, because our code is not just better, it's also understandable, it's nice. We lose the imposter syndrome by understanding everything that we do, and we just go back to the code and say, I remember what I just did. So then, as well, it works pretty well with CI/CD. It's pretty nice for us to detect bugs pretty early while we are just creating the test. We can refactor code without any sort of worry about, okay, maybe I'm just going to break something in my next release. Because no, we just run the test and we make sure that everything is just working properly. The debugging time, as I mentioned, is just being reduced, because now we don't even need to debug some things that we can just know that if we run the test, it will just work, or we just won't, and we just make the refactoring if it's needed. And then I speed up the long-term development, but I actually think that it speeds up the short-term development just by creating some small stuff that I was doing just for playing with that. I noticed that I can even write code even faster when I just start with testing. If I compare it with what I would do only without testing, sometimes it takes more time than I supposed to, and it's kind of, I didn't expect that, so it was pretty nice. Also, self-documentation, as I mentioned, is pretty easy, not just for you, but the other people in the team that need to know how this code works. They just need to see the test, and they know what is happening, and if they break it, they will know. And that's why it increased confidence for any of us, not just for yourself in the team. So I want to take some time to show you a bit let me check 1 second. I want to show you how to actually implement tests. So this will be kind of basic. Wait 1 second. So okay, let's see. I will assume that all of us have some notion about testing, but I want to keep a really basic example about this. So let's say that we have our mark calculator class, and we need to work with a new feature that we have to do. Let's say that now we are going to work with a divide method. But since we are working in test-driven development, we are not touching the class yet. We know that we are going to start with the test, and the idea is that we want to create a method that's going to call divide, let's say. So when I call my divide method, well, actually I need to see it like this because I don't see it. Okay, divide. This is the device test, but for the moment I want to say that it returns a valid number. Okay, so this will be the test. I would like to say that because of this, I also want to initialize what I need, so I just need my class. So since I have my class here, it's like I would say like calculator, and then I instantiate my class. So after taking this in consideration, I would say, I already make the arrange, so I prepare everything that I need. After this, I act. It depends on what what I actually want to do. So I know that I want to know the calculator method that is going to be called divide. And let's imagine that I will send two numbers like 10 and 2. And as you see here, there is already a problem because we have this method that is not being defined. So maybe we can go to the class now and make some implementation where I say, I want to return, let's say, an integer. This method is going to be called divide. And I take two parameters. But let's say I don't have enough good practices and I just call everything dynamic and I just do it like this. So I work on this. Then I make sure just because I want this test to pass, I just return 0. I don't know how to implement it, so I just go continue. So the test works. Then I can actually work with the spec, and I say, well, actually I want to store this in a variable to say result, and say, okay, my result will be basically what I just have, and by logic I would say that I want to return 5. So if we run the test like this, well, you might be already imagining what is going to happen, and it's going to fail. Why? Because there is no test implemented yet. And you say that we are expecting 5, but we get 0 because the method is the only thing it's doing. So maybe we can implement that now. So let's say that we take our number. Let's say I want to return an integer from this. So let's imagine this situation. So now we just run the test again, and we know that it will work. Oh, let's cross the fingers that it works, huh? So it passes. But then we notice that, okay, this test is the happy path. There is no issue. But what happens if we test some scenarios where I know that it will fail? Or maybe I don't know if it will fail. So let's say that it should return, let's say, 0. From this call, like it returns 0 when divided by 0. Actually, it should be a better naming, but I will say it like this for the moment. Should return when divided by 0. So again, we make this test. Oh, it's actually hard to see it from here. Okay, whoops. Okay, debugging time, 1 second. All right, so we have the test. And then, as you might be expecting, we are reusing this class more than once. So we can keep some principles from Drive, and we can say, okay, I want this code to be repeated on all of my tests. So I will say, okay, from this, I will do the setup where I say that I will instantiate my definition of the class every time I want to work on a test. So now I don't need it. I don't need it there. I can just work normally as I want, but because of this, I will say that this is going to be instantiated later. And you say that your calculator is going to be, whoops. Calculator. Okay, like this. So if you follow me on this idea, right now you see that it's a very simple example, but if this helps, it's the base of everything that we are doing, because then if you say, okay, let's work and let's make this final result will do the same thing that we just did before. We just call the method, and then we call divide, and then I say, well, I just want to divide 10 by 0. And we do the same, where we expect, and then we say that this result is going to be 0, because that's what I'm expecting. Oh my goodness, I didn't know. There you go. Okay, if I run the test, you might be imagining it's already going to fail, because I will have some exceptions. The integer division by 0. So I'm not handling that. So now let's go to the code again. And then we see that Basically, if I say that my dividend is going to be 0, well, I just make the comparison where I say, well, this is if it's as long as this is not 0, well, I do this operation. Otherwise, I just return 0. Wait. So this should be the idea. Now, if you run the test again, we might encounter that, yeah, indeed it passed. But now we are not covering some other issues that are very obvious right now. For example, what happens if this method is being called just directly from the user input and they put in a string or something? We don't need to write a test on this. Basically, we just take this dynamic, and since we are good developers, we say they should only accept integers. And then we can take it even further, and then we make it as name parameters. So we just, wait, before going to the test again. Because if we call the divide method, well, I would like to say that I want the dividend, which is the name parameter for this that I want to call, and then the divisor. So as long as they are calling, when I call this method, I wanted to call it with this name parameter. So this doesn't work because it's not implemented. So we can do it right now. And then we do it like this. We take the two integers and we make it required to make sure that we are always dividing one number against with another. And then I noticed that we are calling it A and B, so this is not very descriptive. People don't know actually know what A means, so we can call it dividend, and then the other one should be, well, divisor. Oops, I deleted. And well, I just made a typo here. Okay, now this test should pass, but I also need to fix it for this one. All right, so now if we run the test again, this should work. Now, I want to do something more meaningful here. I know that this test is only for one method that I have in this class, but what happens if we have more classes? Well, by working with tests, we can make groups. In this case, I just want to make sure that this test is about the divide method. So I will call it just divide test. And inside here, I can include everything I want, even the setup. But depending on your needs, I know that for this example, it's not completely needed. Maybe I will use it in other cases, but we can just take it and pass it here, and it still should be good. Then we just run it directly on the group instead of just going one by one. But then, if we are going to be more descriptive, oh my goodness, this word. If we want to describe much better what we want to do, well, we can actually make another group. Woo, where we are saying that this is actually a test for my class. So my calculator test. So just to give a name, but of course it has to be with a better naming. And then we just pass it here, and then it still should be good. If we run it, we know that it works. Okay. If we follow this, I know that it's really basic. In a real world scenario, we are dealing with so many stuff. If we go back to the example that I was talking about, first, what I just did, this mouse disappears when it wants. Huh? What I just did was partitioning. I'm only testing exactly what I want. I'm only focusing on that, and also I'm testing some boundary value analysis. In this case, I know that the division by 0 shouldn't be allowed. It might give you an error, so I'm handling those cases, as well as the good cases. But what happens in other scenarios? Like we are working with state management, and we are working with data from local storage, and then we also want, depending on the situation of my internet connection, I want to call for remote, and also I want to also decide whether I want to get it only from local. What happens as well if there are some classes that depends on another one, and I need to inject them? Well, for those cases, welcome for my second demo. In this one, I actually would like to make it a bit more in detail. I hope that you're a bit familiar with some details, but if not, I would like to explain because it's actually really important for you to understand this. So I decided to work with an architecture called clean architecture. In this way, I decided to work with this because it allows me to separate everything that I want to work with in a pretty well-defined way. So I only test exactly what I want. So for example, as you see here in this lib folder, I have the features folder. This feature folder has one feature. For my test is weather, and this has data, domain, and presentation. So if you're familiar with this kind of working with this architecture, you know that the data layer is only responsible of what is happening in the outside world regarding getting data, sending data, deciding whereas we are working with the local storage or with something related to the remote source. Everything is handled here. We are creating the structure of the data that is coming from the side world. It can be JSON from the API. And then after this, we divide it in different folders that can, as you can see here, we have a class specifically only for the data that is coming from our devices or from the outside world, some models that we might be working with, and the repository that is actually handling the way that these two are actually chosen. Then the domain layer is just the focus of the whole application. It's actually the core of everything, how the application is going to work. So if you wonder, how do I make sense that this data layer is actually giving me back what I need? Well, the domain layer has an interface that has to, well, I would say a contract. In Dart, we can use the abstract classes of interfaces. So I define an interface in the domain layer, as you might be seeing here. For the purpose, there is only one method that whoever needs to implement this, they need to override my methods. In this case, they need to override the getWeather. I'm using some functional programming package that is called darts. So in this case, I know that they will be overriding my asynchronous operation where they either return a failure or, in this case, my right response is a weather entity, which is a class that I define here with freeze class. With the freeze annotation, this allows me to work with immutability and at the same time to remove some boilerplate code, like to define and test from JSON to JSON, things like that. So if we come back here, they need to override this. So the data layer is going to implement that for me. I don't know how, but I just know that they will provide exactly what I need once I call it. So as you see here in the data layer, they are implemented in my class. In this class, we are using dependency inversion, where instead of just working directly with the class, I am just only working with the interface. So I'm not working with any kind of details. And then I also import the network information, and I work with some logic. Then, how does the core of my application communicate with my presentation, where all the fun with Flutter exists? Well, the presentation layer is divided in two, I would say, because we have two stuff, the Flutter thing and our side with the state management. For the purpose of my test, I decided to use Riverpod. And Riverpod, indeed, is just a provider that I decided to use. They are going to be working with a class, a notifier class that I implemented separately. So this is the class that I'm going to be testing for my purpose. And then the provider, well, I don't need to test it because it's already tested. So then I have some weather state that I decided. It's just one factory, a class with factory constructors that, depending on my situation, they will let me know, or they will let know to the presentation if this is loading, if I already have data, if I have an error. So if you see, this is the implementation that I did for my class. Then, if you see here, it's like pretty straightforward, no? I hope it's clear. The use cases I have in the domain layer is just a class with a method, and this method just performs a call to one of the classes that I have defined in my contract. In this case, the interface that I declare here. So whenever the use case that is called with this, I know that I will be calling the repository, which is then with the name getWeather, and then I just pass the params. And then for this example, I just wanted to make it really basic. I just communicate with the domain layer, and I just make sure that whoever calls this one, I will just return what I need from this. So the state notifier handles that in their own way, some logic to know what to present to the user, and then the widgets don't need to worry about anything else. They just need to know, okay, I just made this call, and then I'll just wait to see what to show. And that's it. They don't work with any kind of logic. They don't need to worry about that because everything is handled outside. And then I just instantiate some classes to work with singletons, so only one class is being used once it's being instantiated. So if you see the test, now I know that this might be a bit confusing or a bit hard to digest if it's the first time. I hope it's not. But what is happening is that once we have this, a really well-defined way of how everything is working, everything is very separate, all the concerns are exactly divided, we can test whatever we want. No matter what we have to test, it's just really simple. And then we can just go to our test folder. And if you wonder where do I find my tests, well, they can have the same structure that you see here. We have the lib folder, and well, the test also has the core and the feature. The core is in case I have another feature, and this feature use something that I already use on my other feature, but it's not exclusively for that one. But there are things that I also want to test. So I do the same thing. I have a data layer, a domain, a presentation. I don't need to test everything. Sometimes I just have one class, and this class is only a representation of what I have, let's say from JSON. So it's not actually that we have to test, and some other stuff that are really not that important. But what I need to test is actually the functionality. As long as I have a class with some logic with a method, I know that I have to make a test. So I have a mock file where I'm actually using the mocktail package. It's an upper level package from Mockito. Actually, it's inspired by Mockito, but it makes testing it a bit more easier. So you don't have to worry about some boilerplate code that Mockito already does. I just know that I'm mocking some interfaces depending on my situation and some mock data that I want to use. So now, let's go exactly with the test. I know that it has been a bit long, so I know that I have a test for my use case. I want to use a really very nice and a small example to give you the idea. So I'm going to domain, I have my use case, and I will put it right here. Okay, it's already working. Okay. Yeah, as you see here, this class is implementing an use case. Actually, this use case is just one interface that I define the type of the data that is going to be returned and the type of the params that I'm going to use for the only method that is going to be called, that in this case is called. So I define that it's going to be string and a weather entity, which is the class that I already showed you. And what do I need with this? Because when we are testing, we need to ask some questions, like what do we need to test? What does this class need? And by looking at our example, we know that we need to have some mock classes, in this case for the weather repository, because we don't want to call directly that class. So we need to find a way to mock it, and mocktail already allow us to do that. So what I do here is that I will instantiate a class for my use case, and I will mock the class that is going to be injected. And once I declare it here, I just inject it to my class, and then I'm ready to go. I go to my class here, and then I say, okay, I create my group that is going to be dependent for my class, and then I'm going to make another group for my case for this call. And then for the purpose of this test, mocktail give us a really nice way to work with this mocked version of the classes, because we can hijack the methods, and we can say, okay, whenever this call is done for this method of this class, I want to give a specific response. So what I'm saying here is that when this method from the repository is called with a variable that I define here, I will return this write from the darts package. I know that I want to return, if it's successful, I want to return write. So this will be a weather entity response, and if we see it, is the type that we just defined. And because this is an asynchronous operation, I define here that it's then answer. If for some reason I have one method that it doesn't need to be asynchronous, well, I can just make it like then return. Or if it's an error, well, I just throw an error. But for this purpose, it's a then answer. and this should be the syntax. After making this, we know, okay, there is nothing else that we need to prepare. I know that all my classes are already mocked, the ones that I need. Then I can just go directly to the act, and then I say, okay, I'm going to use the use case call, the one that I just implemented here, and then I will call it with my variable called city name. In this city name, you see here is Antwerp. And after that, if you notice what I'm doing here, well, I'm just expecting that once I make this call, the result will be right, and hoping that this is going to work. Well, it should work. After that, I verify that I make the call, and then that nothing else is happening. But I don't know if someone already like noticed a big problem with my implementation. No one? Well, if I give you a clue, since I'm already hijacking this, I know that depending on this call, I'm returning the right answer with this. But what happens if I'm not calling Antwerp and then I decide to say Brussels? Will it still be working? Of course not, because what is happening is that it's not actually calling the mock version of the class. So it's actually telling me that it returns null because it doesn't know what to do with that. I mock the class, but I'm not doing anything once I actually making a call. So you have two options in order to fix this. You either pay attention of what you're testing and say, okay, maybe I want to say I want to return the city name, which is the same, and it will work. Or you can capture more general cases and you say that no matter what you pass to this method, no matter the argument, I will just want you to return this. If this is a name parameter, let's say that is city, well, for the any you need to specify that it's going to be name, and then you make a reference to the name parameter. Oops, and it should be something like that. But this is not the case, so we can just declare that it's any. And it should be basically like this. So now if you run the test again, you might be thinking that it's going to work, but again, it won't, because it's actually doing something else. We are calling, again, Brussels. Okay, I'm calling it with whatever the argument I pass, but I'm also verifying that I'm not just calling this method from this repository, I'm also asking that this was being called exactly with the arguments that I chose. And I'm not choosing Antwerp, as you see here. I'm actually calling Brussels again. So I know that I first need to make sure that I'm making the right call. So I need to make sure about the naming. And also, since the purpose of my test is not just making this call, but also making sure that it's just exactly what I need, I can just go here and say that it has been called at least once, no more, because that's the only thing I need. And then after this call, I don't want anything else to happen in my repository. I don't want that another call is happening without me noticing. So that's why this verify is really important, because now if you run the test, we know that it will work. But if you want to understand a bit in detail why this is working and why you should be worrying about also verifying and not just testing, let's say that we have our await class, and this class is making a double call. So this double call doesn't create any bug at all. No one will notice it. But of course, we're wasting resources, and at the same time, it's not very optimus. So you can call it. It won't create any problem. But on testing, we are checking that we only want it to be called once, and what is going to happen is going to fail because we are calling it twice. So it's actually the return is based on the logic that we just implemented here. It's not just to say, I will replace whatever the implementation is in the real implementation. And I will just replace with my actual response. The actual response, it depends on the logic that you implemented on your method. So it actually works. So now if we actually do it in the right way, I notice, oh, yeah, that second call wasn't needed. So I just modify my code and then I test again. And I know that it will still work. I hope everything is clear. I see you're like very quiet, but I think everything is understandable. The reason for all this is because if you notice, there is not much going on. This class, I don't know how this class works. I just know that as long as I instantiate it, there are some methods that I can hijack with the mocktail package, and depending on that, if it's implemented correctly, I specify some behaviors, and after that, I just make sure that all my tests is exactly what I'm expecting, and the same thing for the rest. I just handle some issues, like the error handling, and since this is a very small scenario, well, we don't actually need to do like very complex stuff for this test. And you might be thinking, okay, what happens with the rest? The rest is actually the same. Since we have a really well separated way to divide the code and to test it, actually test is not hard at all. Actually, I'm having fun when I test, and then I notice and I feel really confident that what I'm doing is it just makes sense. Anyone who reads my code is actually understanding what is happening because it's just very described here, and there is nothing that might be like a huge mystery for the other developers. If we see, for example, the class notifier that I am testing here, and then I will put it here for you. If you see here, I'm also working with the same thing. The way to work with the state notifier with Riverpod is just a bit different. Actually, there's a nice package if you are working with Riverpod, you can use this, but the syntax is basically the same. You instantiate the class, you set up some changes depending on what is happening, some calls that are actually happening, you just define what you're doing, and then you make the calls that you're expecting to do in your test. And then the skip for this one is because, as you see here, after the class is instantiated, I'm calling the init, and this init is calling a default value for my test. I just wanted to keep it really simple, but it's making one call. So for my expect, I don't want to include that call, so I just skip it, and the expect is the same. So after I make this call, I know that the state of my state my state notifier is actually a weather entity that in this case is a class that I have been mentioning from the beginning, this one. And as you see here, the same thing happens in all cases. If you also notice in the data layer, and then you notice, okay, how am I managing my sources for getting data from the outside world? Well, it's just very simple. I know that I have one class, I instantiated its their interfaces, and those interfaces are communicating like in the same way. So if we go to the test, 1 sec. Oh wait, no, it's in the repository. We do the same. We mock 3 classes, and then we use this class that, as you might be seeing here, and we inject those mocked versions. And the same thing, we mocked the methods that we are using depending on what test we are working on, and depending on that, we just manage the logic, and as soon as it fails, we find something in their code that doesn't match what we want, well, we're just going again to our code and make the necessary changes that we need. And for that, I'm not working with some code that is really hard to understand. I'm just writing the code that is just necessary for me in order to finish what I have to do. And by doing this, I don't think there is any worry or any issue by testing because it's just very well separated. So this is what I wanted to show. I wonder if you have any questions related, or it was clear. I wonder if I have time.
I still have a question maybe.
Uh-huh.
If you could just go back to the demo.
Uh-huh.
Regarding the validate or verify no more interactions.
You mean, well, I can choose any, but
Yeah, I think you have one on the right.
You mean for the use case, for example?
Yes, you do. So, do you have a strategy on saying you never forget a dependency that needs to be verified? So, for example, if you add a new dependency and all your tests succeed, but you forgot to add the verify no more interactions, do you have a strategy on always checking that on teardown or something like that, or a plugin that generates some code for you that?
For the moment, I'm not creating something like that just to generate the code for me, which will be even better. But what I'm actually doing is that depending on my cases, I just did it manually, but if I am understanding your question correctly, um, my strategy is just is doing it for now manually. There is nothing extra that I'm deciding to do. But indeed, if you want to to not to worry about this every time you make a test, yeah, it will be nice to make it a bit automatic. But it's not something that I has been done for at least for this test. I just wanted to keep it really simple because I think it's already a lot. So, but yeah.
And would you always verify each dependency for each test, or only the ones that you're using?
If I'm really sure about what I'm writing, I would say that there. If I actually the verify is only if you want to be extra sure of what you're testing. So it's not mandatory. You can even run the test without any kind of verification, and it will still pass. But if you're just like me, that I'm just still skeptical about what I'm doing. I just want to make sure that when if it's a really simple call, a really small method as you see in the use case, well, I know that no one will have any sort of complication understanding that there is only one call happening. But if the logic is just a bit more complex, and you don't exactly know where the code is going when it's running, I would say that it's wise to add the verification just to make sure that you're just calling exactly what you want, because also you can verify that one call hasn't been performed at all. So it will be just to make it extra sure for you to know that nothing else is happening.
Yeah.
Mm-hmm.
Okay,
So yeah, you're welcome. Any other question?
What about widget testing and screenshot testing? Have you some experience with that? Because we already did it on our projects.
Mm-hmm.
It was quite some time consuming to set up.
Yeah,
You
indeed.
already tried to set it up and maybe you have easier approaches to it.
Well, not sure. Well, I might be answering the question just a bit later with some packages that allows you to work a bit easier. But for this example, I didn't include the test for the widgets. I wanted to show you how the app looks actually. But what is happening in this case is that I didn't test the widgets, since we have the advantage that Flutter has already well tested, unless we actually working with our own widgets, like in a customized way. But I didn't include the test only because I really wanted to focus in terms of the architecture that we can use, so the test can be much easier. But of course, the same thing can be applied for the widgets too, because it's actually essential, and that way we also make sure that our widgets are working perfectly. But yeah, I also wanted to show you the weather app. Basically is like this. So if after the test we make sure that, well, no matter what we do, it still works. But if someone writes something weird, let's say B, well, oops, this is not found. Or if for some reason I go to someone is already working with my API and I say that I want to do with my consents, well, if for some reason the API key is not that one, and then I refresh the application, well, I will still get an error, but a personalized error, or what, depending on what I want. So yeah, it's not authorized because there are some things with the credentials that you need to test. So it's a very small application, as you see, but it covers everything that you need to know in order to fully work directly with the test. So yep, I wonder if I know over time. Okay. Yeah.
Yeah. Do you have a slide with all the names of the packages, the APIs, and things that you've been using?
Yes. Actually,
The reference slide.
yeah. If we go further with this, just to give you to continue with the presentation, this is all the techniques that have been implemented in my demo. Well, in the two demos, where I divide everything related with divided code in a very small portions, testing things in scenarios that we are not common to happen, but we need to make sure that all those edge cases are covered. We are mocking classes and stubbing. The stubbing basically is just to give a fixed value depending on the mock class that you're working. And then the dependency injection is happening at the same time with the mocking, that you are actually injecting the mock class in this case. And by following all these four principles, it's just much easier to test everything. these are useful packages that you can use. I hope this is what you're actually waiting for. You can choose Mockito if you want. I just personally prefer Mocktail. It's just easier. There are some other packages that you can see if you want, especially for widgets are the ones below. So you can take a look or take a picture, or I can even share the slide if you want. And just in order to finish, oh, sorry, you were taking a picture? Anyone? No, okay. I know that this is very outside code, but as you see just below, the way that we live our real life is actually a reflection on how we work. So if we are just messy and we just put everything as we want and we don't care, it's actually really likely that it's going to happen in the code. So as long as we have a really well-managed way to live as well, like going outside, eating well, being clean and organized, this is also a mindset that is going to be reflected in the way that you also work, in this case in our code. So if you also do it like this, well, you have a really good advantage, but there is always a good room to improve. So I just wanted to include in this slide also to give that idea. And yep, that's all my presentation. I hope you like it and everything was understandable.